Hello, welcome to this brand new episode of At School With. Today, we're talking about sustainability and its particular relationship with materials. Sustainability is a very interesting term. It is one which we have been familiar with for some time, but how much do we really know about it? And what does it really mean? It is an important topic for the 21st century as we are in a climatically challenged time. Therefore, it is imperative that we really think how we manage and use the resources of the world. Sustainability is a very important issue for interior architects and designers, particularly when we think of the spaces we create through the use of very specific materials. Along with building reuse, sustainability in our material use can make a big contribution to making our buildings enduring and thus reducing their impact on the planet's resources. In essence, sustainability is an issue that is global and is connected to all forms of human activity. That is to say, it is a vastly complex issue. It can seem an onerous and overwhelming task to consider all aspects of sustainability. But what can we do about this? This episode argues that whilst overwhelming, it is better to do something and to do it consistently rather than to avoid or disregard it. Put simply, however small, doing something is better than doing nothing. My colleagues and I, the Materials Council, a London-based consultancy, wrote this episode. To begin with, we want you to understand that sustainability is a loaded term. It is one that is connected to the best of contemporary design, but it has also been co-opted by some unscrupulous manufacturers as a marketing tool. So, it is important to be clear about what it means and how it is useful. These are the words of the Material Council. They say, sustainability is what we do to enhance the lives of people everywhere without compromising the lives of the future, to ensure the health, vitality and prosperity of the planet. This is clear, succinct and speaks to the heart of sustainability and the agendas around it. This approach will form the basis of our talk. So, how might this relate to the work that you do as a designer, in particular to the design of interior spaces? Building construction accounts for approximately a third of annual global CO2 emissions. It also consumes a large proportion of our material resources. Every building has an interior. Interiors are created or altered at greater frequency than the shell of a building, its structure and its core. This gives interiors significant impact in sustainable approaches. You must understand that you, the interior architecture and designer, will have a substantial effect on the way in which we manage our resources before, during and after a project. This material effect will include the implications of the interior's further replacement and its subsequent reuse as well. So in short, questions of circularity are the fundamental concerns in the designing and making of inside spaces when considering sustainable approaches. Therefore, I feel it is very important to restate, as a designer of inside spaces, this is the opportunity for you to make a substantial and positive impact on the way in which we manage our resources through thoughtful and considered approaches to material sustainabilities. In order to help you with this, in this talk, I will suggest that there are 3 ways of describing how sustainability in materials can be utilised and understood. They are: 1. Minimise embodied carbon. Embodied carbon is the most important single measure of sustainability. Embodied carbon is the value for the total greenhouse gas emissions resulting from the extraction, manufacturing, transportation and use and disposal of a material. Greenhouse gases are the primary cause of global warming and therefore a key contributor to the climate emergency. It is well known that we must act quickly to reduce these emissions, and we can do that through minimising embodied carbon. For the interior, we must use materials with a low embodied carbon. Use less, waste less. Avoid secondary finishes. Reduce transportation. Design for durability. Our second recommendation is we need to promote health and well-being. We spend up to 90% of our time indoors, inside the microenvironments we create. Therefore, humans are hugely affected by the quality of their inside environment. The materials used impact our physical and mental health. It is imperative that we design interiors that do not harm us. We should always design interiors that allow us to be safe and healthy. The most common health impacts in interiors are as a consequence of off-gassing. Off-gassing is the process of chemicals migrating from a material and entering the air, which is then breathed by the building occupants. There are an intimidatingly large number of chemicals that are harmful to our health. Chemical emissions can be grouped together and quantified under the heading volatile organic compounds, VOCs for short. Under universal law, VOC emissions are the primary metric for a material's impact on human health. So, how do we promote health and well-being? Use materials with no or low VOCs. Avoid synthetic adhesives. Use materials that actively improve air quality. Use natural materials. Use inherently antiviral materials. Thirdly, we suggest conserve our planetary resources. The planet is finite. It is a closed system, and we are consuming material resources at an alarming rate. For example, if we take the world's annual steel production and divide it by the world's population, each one of us causes 200 kilograms of steel to be made each year. If we took this steel to make a sculpture, it would have the same volume as an 8-year-old child per person. With the Earth's population set to increase by a further 2 billion people by 2050, our consumption will only continue to increase unless we change the systems of consumption. So, how do we conserve planetary resources? Follow the principles of the circular economy. Use less materials. Use renewable materials. Use materials that are recycled and recyclable. Use certified timber. Design for disassembly and design for longevity. So, now let's look at all three approaches to sustainability in more detail. I am going to describe how they relate to you, a designer, architect of the interior, with the view to helping you make some informed choices when you next think of the materials for your specific project. What is embodied carbon? Embodied carbon is also known as the carbon footprint. It is the measure of greenhouse gases emitted as a consequence of creating and using a material product. This can include the emissions resulting from a material's excavation, production, transportation, assembly, installation, maintenance, replacement, demolition and disposal. Essentially, its whole lifetime. Embodied carbon is measured in carbon dioxide equivalent, or CO2e for short. CO2e accounts for the emissions of all greenhouse gases, carbon dioxide, methane, nitrous oxides and ozone. For ease, CO2 and carbon will be used as shorthand for CO2e in this episode. Why is embodied carbon important? Embodied carbon is directly correlated with climate change. As a measure of greenhouse gas emissions, it is directly correlated to global warming and a major cause of anthropogenic climate change. Embodied carbon in construction is a significant proportion of global emissions. Approximately 11% of total global carbon emissions. Reducing embodied carbon reduces our emissions today. It is widely accepted that the next 20 years are critical to avoiding the worst effects of the climate crisis. As embodied carbon represents upfront carbon emissions for buildings, this is what we must minimise to rapidly reduce our emissions. Prioritising embodied carbon reduction leads to other environmental improvements. These can be more recycled content, better or shorter transportation of materials, and less waste. These will often lead to reducing embodied carbon as well as improvements in other measures of sustainability as a byproduct of these processes. For example, recycled aluminium has a lower embodied carbon than virgin aluminium. Embodied carbon is becoming increasingly regulated. The Netherlands, France, Finland, California and London already have embodied carbon assessment as a condition of certain planning approvals. Knowledge of embodied carbon is becoming a necessary professional competence. Consider a company like Prof, making acoustic panels from materials that are hugely sustainable in content, waste transportation and energy uses. Acoustic panel manufacturing has traditionally utilised extracted fossil-based materials. These panels utilise potato starch, wheat and citrus byproducts from lemons, limes and oranges, combined with wax and cellulose from carefully controlled tree sources. Along with water, the pulp creates 100% recyclable, bio-based, biodegradable panel. How can we minimise embodied carbon? The general principles for assessing embodied carbon are: considering embodied carbon from the beginning of a project sets intentions and focuses minds. As a project develops, the opportunity to impact sustainability decreases while the accuracy of assessment increases. In order to help you embed these ideas in your processes, here are some tools that you can utilise. Let's start with the carbon budget. Quantifying a project's embodied carbon provides objective information that can be used to inform design decisions. To do this, a bill of materials, BOM, and a list of building elements and areas must be created. Multiplying the area of an element by the embodied carbon of its material gives us a measurement for each interior element, such as walls, floors, etc. Adding these values together gives an estimate of the entire project's embodied carbon. Using this method to produce a carbon budget makes visible and clear the impact of design decisions. Of course, the level of detail depends on project ambitions, time, and of course budget. But go ahead, try a BOM in your next work. In the bill, compare materials using functional and relatable units. For example, marble isn't specified by the kilogram, but as an area or number of tiles. To make useful comparisons, materials must be analysed in the forms and dimensions they are used. This is known as the functional units of a material. The majority of interior materials should be considered per square metre at a defined thickness. This then makes things easier for comparison in the BOM. And finally, the other critical thing to do to get a realistic understanding of a project's embodied carbon, the full lifespan of the materials and elements must be considered. As interiors are made and used, they become a larger proportion of a building's whole life embodied carbon. Initially, the interior fit-out accounts for a relatively small, though not insignificant, proportion of a building's embodied carbon. 1/5 is a fair rudimentary approximation. Don't forget, each time an element is reworked or replaced, there is an additional environmental impact. Therefore, it is really important to consider longevity and durability when designing and thinking through the anticipated maintenance and replacement cycle. Because of this, materials with a higher embodied carbon but longer service life may be justified when considered over the building's lifespan. Just to put this in context, this graph shows the carbon emissions for a 60-year lifespan of a building. The beginning spike is construction, the end is demolition. In between are the operational emissions, maintenance, and so on. The majority of emissions occur up front. This is why not only is building reuse important, but the minimising of carbon through carefully considered bills of materials and carbon budgets are essential. Minimising embodied carbon has to be understood in the context of how carbon can be converted and stored. This conversion and storing of carbon as biogenic matter, that's plants to you or me, is known as carbon sequestration. Fluctuations in greenhouse gas concentrations and a changing climate is natural. This process has been occurring since the formation of Earth. That's about 4.5 billion years ago. What is not natural is the current rate of change, and this is directly related to human activities. The carbon dioxide content of the atmosphere is naturally regulated through the carbon cycle. Crudely put, the carbon cycle involves plants removing CO2 from the atmosphere, using the sun's energy in photosynthesis to convert CO2 into carbon and oxygen. The carbon is used to make the physical bodies of plants, and the oxygen is released into the atmosphere. This is sequestration. We can use biogenic materials that reduce atmospheric CO2 and turn buildings into storers rather than emitters of carbon. Certain materials are excellent for sequestration if managed correctly. Thus, they can also be carbon neutral and thus subtract in your bill of materials and the total embodied carbon calculation. Handy for your project's sustainable credentials. Trees are the lungs of the planet and the Earth's foremost sequesters of carbon. Harvesting trees and replanting them at a sustainable rate is the most effective method we have of removing CO2 from the atmosphere. Europe's forest cover has increased by 800,000 hectares every year since 1990, and only 64% of annual growth is harvested. The amount of wood available in Europe is growing continuously. In Europe, the standing volume of forest is growing by 700 million cubic meters every year, almost the equivalent of the wood needed to build a single family house every second. This means that very little timber needs to be imported into Europe, with over 97% of softwood and over 90% of all wood used sourced from indigenous forests, trees. They are amazing. Carbon negative materials. Where to find embodied carbon values? The other place to look to offset or find carbon negative materials is in their transportation to site. If not thought through, this can lead to further carbon emissions. Differing modes of transport emit different levels of CO2, and larger distances leads to more emissions. Using locally sourced materials not only reduces transportation emissions, but it also connects a project to its surrounding environment. Combining and comparing the embodied carbon and transportation emissions of materials provides an accurate picture of the carbon impact. To help you with more information about your project, take a look at EPDs. EPDs are the best source for accurate embodied carbon data for specific products. EPDs are the documentation of a full life cycle assessment, an LCA, carried out to international standards and validated by a third-party organisation. EPDs give very precise information about the impact of products and can be used to make detail-level decisions. Within EPDs, the key metric we are looking for, embodied carbon, is listed as global warming potential, GWP. As always, check what unit is used for the calculation of GWP, embodied carbon. Look them up. So, to conclude this part, minimising the embodied carbon of a project is vital to how the material sustainability of a project can lessen its environmental impact. Next is how we can promote health and well-being through material sustainability. Our efforts to minimise carbon emissions and conserve resources are to ensure the long-term survival of people on this planet. As well as this ambition, it is important to also zoom in and consider the day-to-day experiences of individuals. It is proven that we are deeply affected by the quality of our environments, in both body and in mind. Spending up to 90% of our time indoors, it is clear that the design of our interiors has a significant influence on the quality of our lives. What are the material aspects of health and well-being? There are three primary drivers of health and well-being. They are physical health, physical comfort, and psychological comfort. On this basis, it is a priority that the design of interior spaces must avoid materials that are toxic or harmful to our health. Protecting physical health is the most important factor. Aspects of comfort and experience is what we will consider as well-being. Materials impact health and well-being through a number of mechanisms. The major elements of these effects are material explicit. So, what are healthy materials? The potential harmful effect of materials has long been recognised as a problem. The now outdated term sick building syndrome has been in circulation since the 90s. Poor health can be attributed to many factors. The complexity of human health, combined with the intricate assembly of a building, makes it challenging to pinpoint exactly the causes of negative health related to interiors. Many of the products we use in our buildings are still, to some degree, toxic. These materials are not chosen out of malice, but for the exceptional performance or low price that they might provide. Regardless of this difficulty, the evidence of the hazardous nature of certain construction materials is extensive and compelling. We now know enough to do better. As an approach to sustainable, healthy materials, it is safest to adopt the precautionary principle, as originated by the Science and Environmental Health Network. If there is a serious concern about a material, even if reliable scientific information still leaves some doubt, it is prudent to avoid the risk and seek a safer alternative. Fortunately, today, there are many materials and technologies available that are very low risk and use virtually no hazardous chemicals. So there are many alternatives out there. Seek them out. Why indoor air quality matters. Poor indoor air quality, IAQ, is the primary health concern when selecting internal materials. The health problems arising from or affected by indoor air quality are considerable. The World Health Organization classified household air pollution as an extremely important risk factor, accounting for 4.3 million deaths worldwide. That was in 2012. If we are to focus on a single aspect of materials and health within interiors, IAQ is the place where we should begin. From the three primary mechanisms that materials impact IAQ, off-gassing, particulates and cleaning chemicals, it is off-gassing that is the primary concern. Off-gassing is the term used for when a material releases a chemical, especially a harmful one, in the form of a gas. When used in the context of interiors, off-gassing relates to materials releasing gas as part of their everyday use, rather than as a reaction to temperature or contact with a chemical. Remember our volatile organic compounds, the VOCs? Off-gassing is commonly the consequence of materials containing VOCs. They are the organic chemicals that readily vaporize at room temperature, meaning those substances become gases that can be inhaled. VOCs include a wide range of organic substances, the majority of which are harmless. For example, essential oils are a VOC. They vaporize and we enjoy their aroma. Candles too. However, there are a number of VOCs that do cause short and long-term adverse health effects. And sadly, many of our building materials contain these harmful VOCs. The smell of fresh paint is a toxic VOC that almost everyone is familiar with. With this understanding, we should avoid using materials that release harmful VOCs. VOCs are prevalent within many interior products. VOC chemicals are used as feedstocks for plastics and in binding resins for products such as composite wood or insulation. They are found in paints, coatings, adhesives, and protective treatments. Therefore, even products that don't inherently contain VOCs often gain them through products used to treat or install them. For example, when concrete is sealed or ceramics are fixed. VOC emissions are often related to the curing or drying of products, such as paint. They are emitted at high levels when first installed and taper off to lower levels over time. Building materials wrapped in protective plastic at point of manufacture and unwrapped at the project site can emit concentrated VOCs when uncovered. VOC emissions from solid materials such as flooring, fabric, furniture and furnishings are initially released at a slower pace and maintain a low level of emissions over a longer period of time. VOCs include a wide range of chemicals which are typically measured collectively and communicated in technical data sheets such as TVOCs or total volatile organic compounds. Some manufacturers do list chemical ingredients separately in their technical literature. The most common VOCs of concern that are present in building products and indoor air, these products known to contain these chemicals in anything more than trace quantities should be avoided as part of the precautionary principle. Unfortunately, it is not yet commonplace for manufacturers to disclose the full chemical breakdown of their products. Further to that, the measurement, regulation and guidance around VOCs is limited and often confusing. The regulations that do exist are little known by construction professionals and rarely enforced. Currently, the reduction of VOCs and the push for healthy spaces is driven by the ethics of designers and clients. So until things change, your own response to these issues is critical. As designers, there is only so much that can be controlled. The most significant influence the design team has is ensuring adequate ventilation and the use of materials that don't emit VOCs. As a rule of thumb, TVOC guidance is 300 micrograms per cubic metre. Indoor air TVOC levels should not exceed 300 micrograms per cubic metre, averaged over 8 hours. To help your interior project overcome the issue with VOCs, it is advisable to build in at least a couple of days of flushing. This involves maximising ventilation before an interior is occupied. It is also advisable to maximise ventilation for the first week or two of occupancy to minimise inhalation of VOCs. This chart shows the results of a study measuring the amount of gases present with and without flushing. An office with identical installations over 2 floors was measured for VOC concentrations. Floor A wasn't flushed, whereas floor B was. The difference is clear, with a significant reduction in the flushed floor. Why indoor air quality matters. Third-party certificates. Finally, there are a number of third-party certificates that can independently assess material products for their health attributes. These provide you with a shortcut to understanding that a material is safe to use. The following schemes are well regarded in the industry across the world. Check them out. So, to conclude this chapter, indoor air quality is vital to the health and well-being of humans in their indoor environments. As we spend so much time in them, it is vital that we, as designers of them, consider and ensure that we are not harming the occupants' health when they are inhabiting them. The third and final part of this episode refers to our attitudes towards the resources we currently have on and in this planet. As a species, we are consuming a stupendous amount of the Earth's natural resources at an ever-increasing pace. To quote one concerning statistic, and there are many to choose from, let's face it, since 2003, China has poured more cement every 2 years than the US managed in the entire 20th century. Consider all that was built in the US over that 100-year period. All those skyscrapers, highways and bridges. China produces the same every 2 years. And this only considers concrete use by China. Appraise all global material use and the picture is alarming. Globally, human activity moves more soil, rock and sediment that is moved by all other natural processes combined. Our rate of material consumption is the dictionary definition of unsustainable. We must change the way we consume and make things. First to consider is what is known as the circular economy. Circular economy principles propose moving away from the existing system of take, make, waste, and instead adopting a system of take, make, and make again and again. Reusing existing resources to make new products in a closed loop. A circular approach. Design has an important role to play in the success of this circularity. It is commonly stated that 80% of environmental impacts are locked in at the design stage. True or not, the idea is worth considering. Designers can ensure that negative impacts are minimised in the creation of buildings and that their materials are able to be recovered, recycled or reused at the end of their service life. Take waste-based brick by Stone Cycling, a Dutch company that makes beautiful bricks from the waste and demolition material from all kinds of industrial processes. A really circular economy. In the conservation of Earth's natural capital, there are 2 cycles we must consider: biological and technical. Biological resources are materials that grow using biological processes. They are renewable. Through biodegradation, the nutrients required for new growth are returned to the soil. Biological resources are considered renewable. They are materials that can be used endlessly if replenished at a greater rate than we extract them. It is imperative to use biological resources in a way that their nutrients remain in the biological cycle at the end of their lifespan. Technical resources are materials, often synthetic, that don't form by growing. They are non-renewable. There is a finite amount of these materials on planet Earth. Despite their finite nature, we use technical materials in a way that they are unrecoverable, and thus they become lost to us. To avoid depleting the planet's finite resources, we must recycle and reprocess non-renewable materials, keeping them in the technical cycle. This requires things to be made in ways that ensures that their ingredients can be recovered and the material qualities kept high. One of the fundamental rules of circular design is to keep materials within their cycles. Technical and biological nutrients should remain so. Too often, technical and biological nutrients are irreversibly bonded to each other, so that they can be neither biodegraded or recycled. Cradle-to-Cradle co-author Dr. Michael Braungart calls these monstrous hybrids. Monstrous hybrids are lost from both cycles. At best, they are repurposed for a lower quality application and eventually discarded. This must be avoided. As a designer, select only products that can be separated into their fundamental cycles. Design for disassembly. DFD for short. Buildings should be designed to be disassembled with the same care that is given to their assembly. Materials must be able to be separated and repackaged for reuse and recycling. To achieve this, design must use materials that can be readily recycled or biodegraded. Avoid inseparable composites to maintain material purity for reprocessing. Mechanical fixings are favoured over adhesive fixings, and information on what resources are within a building should be retained. This is where material passports come in handy. The Belgian company Rotor are very good at this. They take buildings apart and reuse them in numerous ways. This is them taking apart Antwerp City Hall for a new project. End-of-life hierarchy. Finally, at the end of a product's useful life, there is a clear hierarchy for how it is reused. The less reprocessing required, the lower the environmental impact. Reuse involves reusing a material in its current form with minor changes. Upcycling is reprocessing a material for a higher quality application. Recycling is reprocessing a material, maintaining its original quality, allowing it to be used for an equivalent application as its previous life. Downcycling is reprocessing that reduces material quality, leading to a lower quality application. A key idea in end-of-life scenarios is to maintain material quality. Design in a way that materials can be recovered and recycled for an equivalent or better use. So, to conclude, this episode has explored how we might minimise embodied carbon, promote health and well-being, and conserve resources full stop, all in order to make the design of our interiors more responsive, thoughtful, and better designed in relation to our impact on the world and its resources. Now it's over to you.